The two vulnerabilities we'll be covering today are path traversal and file upload vulnerability. First off, we have path traversal, which basically grants a hacker access to a directory that they're not supposed to have access to. So imagine like a shopping application that displays a bunch of items for sale, and it's using this URL with this endpoint, and it has a parameter, say file name, um, that is using to load the file. Now, basically, what happens is there's going to be a file system API that attaches this file name to the end of slash var slash www slash images slash. So basically, what this file system API will do is that it will open this image from that path. Now, suppose there's no defenses against file traversal, path traversal attacks. It's possible that some malicious user can enter this sequence with the second. My pointer doesn't seem to be working. Okay, so it's possible that they use this sequence with the dot dot and forward slash, which basically means to move up one directory. So here, since we're at the directory, that's like 3 levels from the root directory. 3 of these dots and slashes will move up to the root directory. So basically, the file that's actually read will be this slash etc slash password, which, if some of you happen to know, is where Unix-based servers store all of the credentials of all users. So basically, all usernames and passwords will be stored in that file. So that's what path traversal basically is. And there's flawed defenses applied against this sort of this vulnerability that we learned to exploit here. So basically, to recap, um, so this causes the application to read from this file path, and this is valid, which means to step up one level in the directory structure, and this is where you actually end up reading from. On Windows, the equivalent to this, you're also allowed to use backslash in place of forward. So, okay. How do we bypass four defenses, and what exactly are the defenses that people try to use? You might have a filter which looks for this traversal sequence and strips it. But then sometimes developers will forget to come back and actually forget to come back. So they'll strip this the middle traversal sequence, which leaves behind another traversal sequence. So they'll forget to do things like that. Or sometimes you can also use URL encoding. We'll come to what that is when we cover the next vulnerability, which is file upload. But right now, basically what it means is that you know how in URLs there can't be spaces, there can't be question marks or equal to's, because those are special characters that have like a reserved meaning. So typically you'll see like a parameter, and then you'll see um, so typically, you know how this says load image question mark in file name. So question mark and equal to here have like a special meaning attached to them. So does space. Just why you can't just have them lying around in a URL. So more often than not, all of these URLs, they have um, a special encoding for characters that aren't allowed. And typically what you'll see is whatever this code that validates it will first URL decode whatever sequence it is. But sometimes when whatever code is validating and checking for path traversal attacks, it doesn't necessarily always check for whether or not the URL is, after it's been decoded, it could still show the following traversal sequence. And then because you've already passed the point where you've already validated the input and you aren't going to check again. You aren't going to check again if it's a path traversal attack. So this time after decoding, you'll still be able to access directories that you shouldn't be able to access. Sometimes they try to validate what kind of file has been uploaded or what kind of file is being requested by the extension. Except you can always terminate the extension with a null byte in between. So basically, the validating code, the code that tries to validate and tries to make sure that there's no path traversal attack taking place. We look at this .png and think, okay, this ends in a .png, so it must mean that this person isn't requesting some directory above. But later on the server side, you might have something that basically strips this last part that follows the null byte. So it still is a valid file and it'll end up taking you to the /etc/password directory. So based off of this, we have like one lab that I want you guys to try. Um, I'll share this link with you. Please open it on Bubs and we'll try to exploit it. So I already have Verb here open, and this is the one that we're trying to solve. It's file path traversal. Traversal sequences stripped non-recursively. So the title itself should be a bit of a giveaway, which is that they are employing some sort of defense against path traversal, but they're not employing it properly. So once, one second. Okay, so basically, once this traversal sequence is stripped, that's another that remains, but the developer isn't coming back and checking if there's another traversal sequence that remains. So that's all you pretty much need to exploit this lab. Let's see it all work in action. So we can check out the basic functionality that this site has, which is when you click on some article, when you click on some item, it's doing something to first fetch that product and then fetch this image and fetch the description and all of that. So if we go to our browsing, we see that and we find something that fetches an image by filtering by find type. So we see all of these. There's GET requests to all of these files. So I can just forward this to the recruiter. What I notice here is that it is taking a file name parameter. So in place of the file name parameter, I could try, since this is the wrong way, since we're trying to access this, I could try doing this. So, and it gives you a 400 bad request and no such file, which means that it's applying some kind of defense against this traversal sequence. Since we already know a couple of tricks, we know that it's possible that they're only checking for this traversal sequence and stripping that sequence, but they might not be doing it recursively. So once I hit send again, we see that we get 200 OK, and we have all of the users and all of the passwords of all of the users. So that's about it. There's a lot of other challenges that you can solve with this. But that's all that we'll be doing for path traversal. We'll try file upload vulnerability now because the labs are way more fun and you learn a lot around with this. Okay, so basically File upload vulnerabilities arise when you either aren't checking the type of the file you're uploading. So, is that a question? Did someone unmute?
Yeah, could you explain what you did in the last lab? I didn't see it properly.
Okay, so the last lab basically employed some sort of defense against this. So if I had to go to slash etc. etc slash password, and if I try to go back a bunch of directories. By the way, you can apply as many traversal sequences as you want, because once it gets to the root directory, it just stops at the root directory. So it doesn't matter the number of backslashes that you apply. After we basically changed the file name parameter to a bunch of these bunch of these traversal sequences, and then etc password, because that's what the challenge requires us to do. Sorry, maybe I didn't read the challenge itself. It basically tells you that you have to retrieve the contents of this file. So what we first did was that we went to HTTP history. We found all of these GET requests with the file name parameter. Basically, it says get/image question mark file name. So we know that this is going to some directory that ends with a slash image. Um, and we want to traverse up, and we want to go up some directories, and we want to go to the root directory. So we send that request to repeater, and then we put a bunch of these traversal sequences. And then we've appended /etc/password. But when I send this, I basically get a 400 bad request because there's no such file. So that tells me that employing some sort of defense against the use of this traversal sequence. Maybe they're just stripping the traversal sequence. So one of the methods you can try to go up directories anyway basically is what we call nested traversal sequences. So what I'm doing here is basically right. So what I've done here basically is that okay, so basically the developers might try to employ some sort of defense which strips this specific sequence, but then they might not have modified their code to come back and do that recursively. So after this is stripped, you end up with another traversal sequence. So that's one of the many ways of attempting to exploit uh, path traversal vulnerabilities that we could try. And when I do send this request, we see that we get a 200 okay, and that we get all of these usernames and all of these passwords. Is that clear? Did you understand?
Ah, yes, yes. Okay, fine.
Okay. So file upload vulnerabilities basically just means that there is some sort of endpoint that's accepting either PDFs or JPEGs or some sort of user input, but it's not checking that it's the right kind of input. Maybe it's not checking the name. Maybe this malicious user is rewriting or overwriting some other files with the same name. Or maybe they're uploading some sort of script that gives them um, control over the server. Maybe they're not checking the size. So some malicious users can repeatedly send over like large files, and that will consume all of the disk space of the server. So it's very important that you make sure that the right kind of files are uploaded. So file upload vulnerabilities are basically what happens when um, it's not checked correctly, and we'll see how this vulnerability can be exploited. Okay, so basically, there's a lot of possible things that the server does with files. Sometimes the server has to deal with static files. Sometimes it might upload whatever file the user um, is inputting into some place before it checks if the contents are okay. and then it might move it on to like some permanent place on the disk after checking that it's empty. So that could be, you learn race conditions and possibly another session in the future, but we'll look at how all of this comes into play. So basically, if the file that you upload is a non-executable, the server might just send um, the file itself. So it could just request it. But if the file that you upload is a PHP file and the server is and it's configured to execute the file, it'll typically execute whatever file that you've uploaded, like whatever instructions there are, and then it might send you back a response in when you trigger it. So maybe you'll go to some endpoint and you'll request something, and then it'll send back whatever, it'll get executed and send back the response. So the file that you upload, it's not is executable, and the server is not allowed to execute files that are given by users. Then it might throw an error. But sometimes you can change some files in the server that might let you change which files are executable and which are not. And we look at all of this in future labs, in these labs. So right now, what is a web shell? A web shell is basically a script that gives the attacker some sort of power over the server, basically. So first off, we look at how form data looks in a request, in an HTTP request. So this is some sort of request. And when you're uploading like a large file, maybe you're uploading a PDF, or maybe you're uploading some huge JPEGs are technically huge because they have to be broken into chunks. So the mode that the post request will use is this multi-hop slash form data. And you can see that all of these headers, you can see there's a content disposition header, there's a name, there's a file name, there's a content type header. Sometimes the sort of security measure that some website might use is that they might use this content type header to check if this is not an executable, if this really is an image. Except that we know that HTTP requests can be captured through birth and modified by users. So it is not a secure way of checking if the file type is correct or the file type is allowed. So first off, we'll do a lab, which basically involves manipulating these headers somehow so that we um, manipulating the headers so that we can bypass whatever restrictions are there. Send you guys this link. So this lab contains a vulnerable image upload function. It attempts to prevent users from uploading unexpected file types, but relies on checking user controllable input to verify this. To solve the lab, upload a basic web shell and use it to exfiltrate the contents of the file. Home Carlos secret. Submit the secret using the button provided, and you can log into your own account using Viner. So before we start, okay, actually maybe I'll tell you as we do the lab. So we go to my account and say we attempt to log in with our credentials. Viner computer. So here we have something that lets you upload your own avatar and reels, and we can play around with that sort of functionality. And I could just upload uh, some random, some random. So it says, and see how it goes. Okay, so it says file avatar slash whatever has been uploaded, and then you go back to your account. you can see whatever this is. So what happens when you try to upload something that ideally should not be allowed? So this is a shell. I'll show you the contents of the shell soon enough. But when I try to upload something with a .php extension, it says sorry, file type application slash text stream is not allowed. Only image slash JPEG and image slash PNG are allowed. Sorry, there was an upload. Sorry, there was an error uploading your file. So it basically just doesn't upload it and it throws an error. So what's the lab instance? So when I try to filter this, I look for the MIME type image. So we see this post. So this post request is what is letting us upload the avatar. So here you can quite literally see the byte, the content of the JPEG image all sent. And I suppose it also has like a content type header and all of that. So see, right here it says content type image slash PNG, and it let you upload it because it was an acceptable, it was basically an acceptable MIME type. So what I'll do now is I'll find the request that attempted to. So this is the request. Post slash mycon slash avatar, which tried to upload the file name shell. Which tried to upload the web shell. And basically, you can see here that the content type header says application slash text stream. We're going to forward this to repeater. And here, since we want the content type image slash PNG, I can just copy that. And if this is a vulnerable website that's using just these headers, the content type header to check if it's the right kind of file, then we can easily bypass that by just changing that header to image slash PNG. And here's what we get. We got a 200 OK, and it says the file avatar slash shell.php has been included. So when I go back to this and I hit reload, I basically see that it's in fact been uploaded because, and obviously since it's not a JPEG, it can't be displayed. But if I clicked on open image in new tab, here's what I get. This is basically Carlos's secret. As for what that shell actually contains, just open it in Notepad for now. Okay, it basically says php echo file get contents slash home slash Carlos slash. This basically, in place of this, you could have also used php system cat So I'll send it to you guys both of these PHP one-liners. Either of these will work. As for the explanation, the second one basically just opens a shell on the server system. And then all of you know what cat does. And this is basically just the file that needs to be, that cat adds on. And echo file get contents. Basically, file get contents is a function that will get the content of this file. And echo is just something that paste the results of the terminal. So that's what either of these will work. And for the purposes of this demonstration, that's the shell that I'll be using. Okay, so you guys can try that lab on your own. I hope the explanation was somehow clear. Basically, it was vulnerable because They were only checking for the content header, the content type header to make sure that it was image slash PNG or image slash JPEG. But ideally, you shouldn't rely on something that people can change just by proxying that sort of HTTP request through the browser and changing that request because it's very much user controllable. On to the next one. Uh,
Uh, I had a doubt in the previous lab.
yeah, go on.
It's after you upload your shell script, what exactly happens?
So after you upload your shell script, it's basically attempted to display your avatar on this page, right? So if I go through my HTTP traffic, one thing that I see is it says get file slash avatar slash shell PHP. So even after I uploaded the where's the other post request? Okay, so after this post request, which basically was when I uploaded that function and hit on upload, it sent all of this through, right? It sent the entire JPEG thing through. And after that, when I went back to the home screen had to display my avatar, right? You remember this little, there was an avatar displayed at this area?
Oh yeah.
Yeah, so that was gotten through this get request, which basically says get slash file slash avatars and the screenshot that I uploaded. Similarly, so after the post request lets you put shell.php, and after you've changed this to images slash PNG, it gives you a 200 OK and says that file avatar slash shell PHP has been uploaded. And when you go back here, you see that you can't actually see that JPEG anymore, which means this itself is your shell. But since it's not a JPEG, you can't see it. But when you hit on open image in new tab, the shell basically gets executed, and the results of it come out, which is basically Carlos's secret, right?
Okay, yeah, understood. Thank you.
Okay. Uh, okay, so on to the next one. Okay, so this is basically the same thing I told you guys about URL encoding, which is how sometimes these question marks and these equal tos, all of these are not regular characters, they're reserved characters. So they basically are changed um, when you have to give it over a URL. That'll come into use when we look at this lab. This basically says file upload via path traversal. So we'll see exactly how exploit that vulnerability. One second. So it basically says this lab contains a vulnerable image upload function. The server is configured to prevent execution of user-supplied files, but this restriction can be bypassed by exploiting a secondary vulnerability. To solve the lab, upload a basic PHP web shell and use it to exfiltrate the contents of /home/carlos/secret. Submit the secret using the button provided. You can log into your own account using the following credentials. So we'll try to see what happens when you try to upload the shell.php. Your oh what? Okay, so basically what it's done is, if it's a PHP file, it lets you upload the file, but it doesn't let you run the file. So instead of this command getting executed, it just returns plain text. It just returns the contents of the file itself. That in itself is sort of interesting behavior. It's sometimes you'll be able to leak source code from a website because of that. What's the lab instance? So, okay, so basically there's a post request where I've sent this shell. I'm gonna send this to repeater, and basically this is letting me upload the file when I hit send. Basically, this tells me the file avatar slash shell php has been uploaded. But since this directory doesn't seem to have permissions to execute the file, when we open it, we just come back with plain text. So I'll try introducing a traversal sequencer and hitting send. But here, what happened again is, again, it says the file slash avatar slash shell php has been uploaded. But it doesn't seem to, it seems to have stripped this traversal sequence because it didn't change directories. So one thing I can do is I can URL encode one of this. So since we know that this is like one possible way that path traversal attacks can happen, because whatever is validating this input is only checking for the dot dot slash, but it's not checking for this unexpected character. But maybe on the server side, there's something that decodes this URL encoded character. And then on the server side, it's letting you. So yeah, so now we see that you get a 200 okay, and the file, it says file avatar slash shell. So it's going up a directory. And we go here. Uh, we can go to we send this request to repeater as well. This is a get request, which basically tries to get this. So we go up one directory. Here too, I'm introducing that traversal sequence, and we're sending that because we know that it's been uploaded. Seems to be taking a while. But I hope you guys understood what exactly happened here, right? We changed this to the URL encoding of the forward slash that basically allowed us to upload the file slash avatar slash shell PHP. And maybe that directory does have permissions to execute the PHP file, because this current directory didn't have permissions. All we got was the plain text that was in the file back. Okay, so now that that request is gone send, we come back with Carlos's secret here. I submit it. Solve the lab. Okay, so on to the next slide. Okay, so we've covered file upload through path traversal. Now on to file upload via extension blacklist bypass. Okay, so most servers um, they can't execute something like we saw in the previous one. There was a certain directory that wasn't allowed to execute the .php file, but we traversed up one directory, and that directory was basically allowed to execute that command, which is why we got that was a secret. So typically you'll have like one configuration file that lets you specify which extension type is mapped to which MIME type. So basically, this one basically says that .php can be executed and it will be treated as an executable. So many servers also allow developers to create a special configuration file within individual directories that either override or add to one of the global settings. So say that the original configuration file does not let a certain directory upload or execute PHP file. So it doesn't matter if you upload a PHP because that extension still isn't allowed to be executed. So you might just get back the plain text if you request that file. But that doesn't mean you can't use a different arbitrary file extension. So some servers will load their specific configurations from a file called .htaccess. So we'll see how exactly we can exploit that. That's the yep. As this lab contains a vulnerable image upload function, certain file extensions are blacklisted, but this defense can be bypassed due to a fundamental flaw in the configuration of this blacklist. To solve this lab, upload a basic PHP web shell and then use it to exfiltrate the contents of phone Carlos secret. Submit this secret using the the button provided in the lab banner, and you can log into your own credentials. So the hint given to us is that we need to load two different files to solve this lab. And because based on the theory we just read, we know that we could actually upload a .htaccess file. If there isn't already a .htaccess file, whatever we upload will be used by the server to check if some sort of extension is allowed and can be treated as an executable. So we can just create our own extensions, change the extensions to our shell, and then the shell will be executable because our malicious htaccess file basically lets that arbitrary extension be treated as a shell. Okay, so I'm trying to upload this .php file. It says, sorry, PHP files are not allowed. Sorry, there was an error uploading a file. So we go to it says I'm gonna try to find the post request that basically I'm gonna send this to recruiter. And first of all, we're gonna try to upload our own .htaccess file. We're gonna change the content from something that so application/octet string basically specifies that it's an executable, but we want this to just be a regular .htaccess file, which basically just specifies what's allowed and what's not. And going back to my slides, notice how this says add type application slash all of this .php. This is basically a line. Add type is a directive. Application slash that basically just means that you want this specific extension to be treated as a PHP extension. So I've copied that line. I'll send it to you guys as well. So in place of .php, I can just give it an arbitrary extension. I can call it .abc. And that's what I'm going to upload. That's what I'm going to make as the contents of this htaccess file. In in place of .php, I've just basically made it .abc. So what is this doing? It's trying to upload a .ht access file. If we're lucky, the server doesn't already have a .ht access file and we'll use this specific one for instructions. And we've added something that says anything with a .abcd extension must be treated as a PHP file. And I'm gonna send this request. And we get a 200 OK, and it says the file avatars/.ht access has been uploaded. We go back, we try to find the request which was sent when we try to upload the shell. And notice this says shell.php, and in our htaccess file, we said that anything with .abcd will be treated as PHP. So I'm changing the file name parameter to shell.abcd, and everything else is the same. Okay, so it says the file avatar/shell abcd has been uploaded. When I hit reload, we see again that there's something that shows up, but we can't view it because it's actually now the JPEG. And there you go, you have Carlos's subject. Any doubts on this question?
Can you explain what is traversal access?
HT access, okay. HT access is basically, okay, normally there is one configuration file that's used for all the directories. So it basically specifies which extensions are allowed, which extensions are not allowed. Basically like a blacklist or a whitelist. Basically tells the server how to deal with a certain extension. But obviously, developers might want that some directories have different permissions or they behave differently from other directories. Maybe some directories do require uh, uh, that you run some code or that you run some executable that's been uploaded by the user. For those directories, there's something called a .ht access file, which basically you can add directives. You can either add certain extensions and make them behave like executables, or you can override some instructions in the main configuration file. So in this case, we basically just added a line in the .ht access file, which allowed the extension abcd to be treated as a PHP file, as an executable, basically. So this add type is a directive that tells you that uh, you're adding that certain extension. So ABCD was added, and what to treat it as, which is application/x/http/php, which tells it to treat it like an executable. Is that okay?
Yeah.
So finally, we have our last lab for the day. First off, using blacklist is usually a bad idea because sometimes you'll miss a certain extension. So the validation code might let you upload something that says PHP 5. And the server might be actually configured to run that .php 5 as an executable. So blacklists are generally a bad idea. Typically, you want to compare whatever file types or file extensions are allowed against the whitelist. Okay, just as an example, we can see that we can capitalize the H in PHP, and the validation code might be case sensitive and it might not detect that this is a PHP file. And so if it makes it to the server and the server actually considers this PHP with a capital H a PHP file, then it can in fact execute it. So there's subtle discrepancies among so the validation code will be different and what the server does with it might be different. And that's what obfuscation means. You basically just upload confusing names that confuse the validation code. and once it gets through, it gets executed by the server. So you can either you can use two extensions, dot JPEG, dot PHP. Actually, this should be second. This should be dot PHP, dot JPEG. So maybe you have a validation code that looks at this, that uh, splits at every period, and it looks at whatever is output, and it sees that this is a JPEG file, and it considers it safe and lets you upload it. But maybe the server looks at this initial exploit.php and then looks at it as an executable and executes it. Maybe there's a trailing space or a trailing period. And this is considered safe to upload because whatever is following it doesn't look like it's a PHP file. But then the server might look at this and it might actually end up executing the exploit. So we can try URL encoding some characters. We can try adding semicolons. Semicolons if whatever the server is using is similar to C. It gets cut off at the .asp. So it's treated as an executable, but whatever validation code might be splitting in periods, and then it might look at the last split. It might look at .jpeg and think it's safe to upload. You can also try using null bytes like this, which basically allow you to upload something that looks like it's acting with a .jpeg, but then when you go on to actually, when the server processes it, it treats anything after this null byte as the end, because the null byte is how strings are ending. You might also have a filter, like how we saw earlier with the traversal sequence filter. Basically, it removes the middle .php, but then it still leaves behind another .php, and maybe the validation code isn't coming back and checking if there's still a .php. Okay, so that's what we're gonna try to exploit in this final lab for here. Says this lab contains a vulnerable image and function. Certain file extensions are blacklisted, but this defense can be bypassed using a classic obfuscation technique. To solve the lab, upload a basic PHP website and then use it to find the contents of this. Okay, so I'm going to try to upload the shell again. It says sorry, only JPEG and PHP files are allowed. Sorry, there was an error loading your file. I'll try to find that request on there. So it was this. It's this request. I'm gonna send this to repeater, and we'll try seeing if changing the file name impacts this somehow. So I'm going to add another extension at the end of this and make it a .jpeg file, and it says file slash avatar slash php.jpeg has been uploaded. So we can see that it hasn't really, this won't really work because it did not remove the .jpeg. It's just uploaded the whole thing. We could try URL encoding that PDF. and try sending it again. And it still says shell.php.jpeg has been loaded. And in place of that, we can try a null byte. And now we finally see that the file avatar/shell PHP has been uploaded. So we managed to upload the file. Hit sudo. This is basically your shell. We open image new tab. So in the URL, you have to actually remove the null byte and the .jpeg, and you have Carlos center. So that's pretty much all the labs we have for today. And I hope you guys got like a good understanding of file upload, vulnerability, and path traversal.